Okay, welcome. Today we're going to look at proving two triangles are similar using the methods that we looked up yesterday and some of the definitions. Those methods were angle, angle, side, 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 and side, angle, side. Okay, go ahead and get your notes out, and remember during the video to pause the video to keep your notes caught up and complete. And if you're not sure on something, rewind the video and listen to it again. Sometimes it takes a few times. Now we have three problems to do. We're going to look just at two of them. And I think if we do the first two, the third one will be an easier problem for you to do. All right, so let's go ahead and get going. We're going to look at problem number one. So I'm going to go ahead and drag that down here. And we're going to look at these triangles. All right, we need to prove that these two triangles are similar. We have triangle UVW, that's the big triangle, and the smaller triangle are UNM. Now, one of the first things I notice about this problem that's going to help me decide which method to use is I have all the sides. If I have all the sides, by definition of similar triangles, corresponding sides have the same ratio. I can use that concept and prove this by side, side, side. So let's go ahead and take a look at this problem. Okay, so first thing I'm going to look at is I need side UW. So I'm going to look at UW, and UW is the sum of 72 and 32, so I have to do a little math. That's 104. And then I'm going to look at side UV, which is 32. So we looked at VUW and NU. I'm sorry, UN. I'll put the N for U first. Okay, so by doing some quick calculations, that's 104 and 32 in the numerator. And it looks like they have a common factor of possibly 8. 4 times 8 is 32. 8 times, let's see, 8 goes into 10 one time. Bring the 2 down and the 4, that would be 13. It would be 8 times 13. So I divide out my common factor and I have a common ratio of 4 over 13. Now we need to prove the other sides have the same common ratio. So let's pick another side. Let's look at side NM, and that's corresponding side would be WV. Okay, so N is 44 over 143. Now we got a bigger number, but it's okay because we know the common ratio. For this to be similar, it has to be 4 over 13. So I'm going to think a little backwards here. What times 4 is 44? Well, we know that's going to be 11. Then our question is 11 times 13 143? With some quick mental math, we can see that is actually true, so it does have a common ratio of 4 over 13. And that shows us that these two sides are equal in terms of their ratio. All right, so lastly, we want to show that side UM is, and its corresponding side UV have the same ratio. All right, so UM, we don't have UM. We're going to have to do some math over here. We do have UV, though. UV is 91. But we need to go figure out what UM is going to be. So, with a simple subtraction, 63, 91 minus 63, let's see, carry the 1 over, we get 8, we get 28. We know that UM is going to be 28. Again, using the concept that we know what these are, we know our ratio needs to be 4 over 13. So 4 times 7 is 28, is 13 times 7, 91. With some quick mental math, we show it is. So now we've shown that all these sides, the ratio of all these sides are equal. We proved it down here. So now we can make the claim that triangle UVW is similar, and there's the sign for similar, to triangle UNM. Okay, let's move on to the next problem. Okay, the next problem, we're going to look at this triangle here. So let's talk about this one. I'm going to drag it down so we have more room. And I want to prove that these two triangles are similar. The first thing I notice is I have some new notation. The red arrows that you are seeing here and here indicate that these two lines are parallel. That's going to bring in a lot of stuff that we know now from the definitions of yesterday. I also noticed that I don't have any side ratios or side links to create ratios. So I can get rid of trying to prove these similar by using side, side, side. I can also get rid of using side, angle, side because I simply just don't have the ratios. So to prove these, we have to use angle, angle. So I need to find two consecutive angles that are congruent to their corresponding angles on the other triangle. And the first thing I noticed is I have vertical angles. Okay. So we can say that angle LJK, angle LJK is congruent or the same as angle EJF. And our reasoning is they're vertical angles. So I'm going to abbreviate. Let's go vertical. Okay, so that's our definition of vertical angles. So we've got one set of angles. Now we need to prove either this angle or this angle is congruent with its corresponding angles. Now yesterday we learned about congruent angles and corresponding angles using two parallel lines and a transversal. But what I have here are two parallel lines cut by a transversal. So I can say, using that definition, that angle K, so let's write it over here, KLJ is congruent to angle FEJ. And my reasoning is that these are alternate interior angles. So let's go ahead and write the reason down and discuss it. Alternate abbreviate interior because they're inside. Now let's just spell it out. Angles. Okay, so we're saying this one is congruent to this one. Now if we look closely, if I were to extend this line, this parallel line, I can see that this is the smaller angle or the acute angle, while the other side would be the obtuse. If I go over here, I can see that this too is also the acute angle where the other side is obtuse. So the acute angles will be congruent. They're alternate interiors because they're inside the parallel line. Okay, we've just shown that these two angles are congruent. There's our justification. So we can say that these two triangles are similar by angle, angle. Okay, to write our claim, we're claiming that triangle JKL is similar to triangle FEJ. So we looked at one triangle that gave us side ratios, which opened up side, side, side. We looked at another set of triangles that had no sides, so we can't use anything with a side, so this opened up angle, angle, angle. And if we look at our last set of triangles, which we're not going to work out, we'll be combining the two methods. I've got sides, corresponding sides, and congruent angles. So I could probably easily say that side, angle, side might be the way to go on these two triangles. Okay, if you have any questions, make sure you write them down and ask them during class, and hopefully this will help you get through our assignment.